Greetings. My name is Mrs. Lyons. Welcome to Chemistry from the Lion's Den. Today's topic is significant figures. So, once you've finished watching this video, hopefully you'll understand why significant figures are important. You'll be able to apply the rules when given a number to determine how many significant figures there are in that number, and to carry out mathematical calculations, addition, subtraction, multiplication, division, and give your answer to the correct number of significant figures. So before we get going with some rules and how to count significant figures, we want to know why sig figs are important. I abbreviate sig figs, you'll often hear that instead of the whole term significant figures. But sig figs, what they are the digits in a measured value that are known with certainty, plus one digit that we estimate. So anytime we're thinking about significant figures, we're thinking about a measured number, okay? And when we measure, we need to make sure that we use our measuring device as it's intended. So if I look at this picture of a pencil, I want to measure the length of the pencil, and those lines are kind of small, so I'm just going to kind of blow that up. So now if I look at this, I can tell a couple of things. I can tell that my pencil is somewhere between 18 centimeters and 19 centimeters. I know that without a doubt. Each of these littler increments up here represents 0.1 centimeters. So I can also say that my pencil measures somewhere between 18.7 and 18.8. Okay? So in my measurement, the 1, the 8, and the 7 are all certain digits. We know that this pencil is somewhere between 18.7 and 18.8. I estimated the 3 as my last digit. Now, if you used this ruler to measure this pencil and you came up with 18.72 or 18.74, your answer would also be correct because the 1, the 8, and the 7 are there, and those are the certain digits. The 3 is an estimate. So if my estimate and your estimate are different, that's okay with that one place. So why are significant figures important? Just like with the ruler, we can see how precise our measurement is based on the increments on the device we're using. So significant figures show us how precise our measurement is. And if you string out a whole bunch of digits without having them listed on your measuring device, it makes the measurement very misleading. Many of the digits in that number. So there are some rules for counting significant figures. When we look at a number, we're assuming it's a measurement, and we want to make sure that we're counting the digits that are important and not counting those that are not important. So we got rules for 4 different things. The first one is relatively easy. All non-zero digits are significant. So if I look at a number like 234, all of those are non-zeros, so that number has 3 sig figs. 48,921, again, all of those numbers, all of those digits are not zeros, so they all count. I would say 48,921 has 5 significant figures. When we get to the zeros, this is where it gets a little bit more challenging to figure out if they're significant or not. We're going to talk about 3 types of zeros. First, we're going to talk about trapped zeros. Trapped zeros are zeros that are in between 2 non-zero numbers. And trapped zeros are always significant. So I've got a couple of examples here. 2,501 That 0 is between the 5 and the 1, so it counts as significant. So that number has 4 sig figs. 25.001, all right? Again, those zeros are between two non-zero numbers, even though there's 2 of them, okay? So those 2 zeros count as significant, so that number has 5 sig figs, all right? The next type of zero we're going to talk about is a leading zero. Leading zeros are zeros at the beginning of a number, and they are never counted as significant figures. So here are a couple of examples. 0.0023, the zeros don't count, so there are only 2 sig figs there. 0.000245, the zeros, the leading zeros, do not count, so that number has 3 sig figs. The last type of zero we need to talk about are trailing zeros. And we save them for last because sometimes they're significant and sometimes they're not. So what makes the difference? Trailing zeros are significant only when there's a decimal in the number. So let's look at a couple of examples. 2,500. Those are trailing zeros. There is no decimal in that number, so that number has 2 sig figs. 25.00. Again, there are 2 trailing zeros, but in this case, there's a decimal in the number, so those zeros count. So we would say that there are 4 significant figures. So let's do a little bit of practice. Here are 4 numbers. All right. The first thing we have to do when we look at a number is we have to identify, is there a 0 or not? If there is no 0, all of the digits count as significant. So 23.45, there are no zeros, so that one's easy. There's 4 sig figs. All right. Let's look at 5,010. There are 2 types of zeros here. There's a captive 0, the 0 between the 5 and the 1, so that counts as significant. And then we have a trailing 0. And the trailing 0 is there's no decimal in the number, so that trailing 0 does not count. So this number has 3 sig figs, the 5, the 0, and the 1. Let's look at 0.0280. Again, we've got 2 kinds of zeros. We have a leading 0, which is never significant, and then we have a trailing 0, and that trailing 0 is in a number that has a decimal in it, so the trailing 0 counts as significant. So this number has 3 sig figs. Finally, 7,000, and I want you to notice at the back of this number is a decimal point, okay? So that's important because these zeros are all trailing zeros. If there's a decimal, they count as significant. If there's not a decimal, they don't. So this decimal there tells us that those zeros are all significant. All right, let's do a little bit more practice. Our first number, 0.0045. Those are leading zeros. Leading zeros are never significant, so that number has 2 sig figs. 105.00. There's a captive 0, so we know that that's significant. And then there are 2 trailing zeros. We look, there's a decimal in the number, so those trailing zeros are significant. So this number has 5 sig figs. What about 500? All right, here we have trailing zeros. Trailing zeros are only significant if there's a decimal present. In this case, there is no decimal. So this number only has 1 sig fig, just that 5. One more, and then this number you'll notice is written in scientific notation, okay? And we will use scientific notation frequently, so it's important to know how to count our sig figs when we see a number like this. But if you look, what we're going to do is we're just going to look at the base. We're going to ignore the exponent part. So in this case, my base is 4.50. how many sig figs in that number. Well, we have a trailing 0 with a decimal, so that is significant. So we, in this number, have 3 sig figs. Okay, so you just treat scientific notation, you just kind of ignore that end part with the exponent. All right, so one more thing we need to be able to do. We need to be able to carry out addition and subtraction and multiplication and division and give our answers with the right number of sig figs. So for addition and subtraction, we count the fewest decimal places. So 8.55 has 2 places after the decimal. 1.2 only has 1 place after the decimal. So our answer can only have the least number of places. So if we do this math, we're going to plug this in, we're going to get 9.75 as our answer, but we can only have 1 digit significant after the decimal, which means we need to round to this 7. Since the 5 is there, it's going to round up. So our answer with the correct number of sig figs will be 9.8. Now, multiplication division. There are different rules. And the multiplication division rules are a little bit easier because all we do is we count the significant figures in each of our starting numbers, and whichever number has the smallest number of sig figs tells us how many sig figs can be in our answer. So 3.4 has 2 sig figs. 5.61 has 3 sig figs. What this means is our answer can only have 2 significant figures. So I'm going to look at this number that my calculator gives me, 19.074. I can only have 2 sig figs, so the 1 and the 9. Since this is a 0, I don't need to round up, so my answer is just going to be 19. So let's do a little bit of practice. If we look at this number, we'll get 3.21 plus 8.8234. Okay, we're adding, so we're going to count decimal places. So this first number has 2 decimal places. The second number has 4 decimal places. So since 3.21 has fewer places, we can round our answer to the same 2 places after the decimal. So if I plug this into my calculator, I get 12.033. All right, I can only have 2 places after the decimal, so the 0 and the 3. Okay, this 3 doesn't make us round up, so our answer to 2 decimal places is going to be 12.03. Let's do another calculation. So in this case, we're subtracting 6.4 minus 2.2343. Again, addition, subtraction, you look at the number of decimal places. So 6.4 has 1 decimal place. 2.2343 has 4 decimal places. Okay, so when we do this math, we do the subtraction, I get 4.1657. If I look, I can only include 1 decimal place. So this 1 would be my last significant figure. I look and see the next number is a 6, so I'm going to round up. And my answer then would be 4.2. When we're doing multiplication or division, we're always just going to count the number of sig figs in each of our starting numbers. So 1040 has 3 sig figs. The trapped 0 is significant. The trailing 0 is not significant. Divided by 36, 36 has 2 sig figs. If I plug this into my calculator, I get 28.88889. Okay, so when I round this to the correct number of sig figs, I see that I can only have 2 significant figures in my answer. So the 2 and the 8 are significant. Since this is an 8, I'm going to round up. So my answer is 29. All right, let's try one more calculation. This one is multiplication, 6.5 times 4,059. So we're going to look at the number of significant figures in each of our starting numbers. So 6.5 has 2 sig figs. 4059 has 4 sig figs because the 0 is trapped, making it significant. So if I plug this into my calculator, I get this number, 26,383.589. I need to round that to 2 significant figures. So the 2 and the 6 are going to be significant. The 3, I don't round up, okay? Now this one's a little bit tricky. You can't just say the answer is 26. You have to remember the value. So what we do is we place zeros at the end for the digits that are not significant. All right, because if you look at the answer, the 2 and the 6 are significant. The zeros are trailing zeros with no decimal, so they're not. So our answer has to have 2 sig figs because our 6.5 had 2 sig figs. So our overall answer is going to be 26,000. Thanks for watching this video on significant figures. I hope it makes sense. Be well and stay curious.